So to get started on this homework assignment, you're going to need your periodic table, a scientific calculator, and maybe an eraser. So there are a couple of videos that you can use to help you understand dimensional analysis a little bit better, and then how to use dimensional analysis with stoichiometry. And so this is the fence method that we've been using in class. But we're going to go through this homework assignment, and you can pause when you need to, or you can speed up if you already know that concept. All right, so for the first part, when we talk about the balanced chemical equation, we have iron oxide plus carbon yielding iron plus carbon dioxide. And we want to know how many moles we have of the following. So we looked at this balanced equation, and we want to look at the coefficients. So the coefficients of iron oxide is 2. So we have 2 moles in this reacting with the coefficient of carbon, 3 moles of carbon, and that will yield the coefficient of iron, 4 moles of iron, as well as 3 moles of CO2. So these numbers come from the coefficients in the balanced chemical equation. Oops, sorry, I need to back up. So the question we're trying to answer today is to use the following questions to solve how many grams of iron oxide you would need to produce 6.3 grams of CO2. Whoop. Okay. So the first step in this is we need to figure out how many moles are in 6.53 grams of CO2. So we look back at the original question. We can see that the given amount is 6.53 grams of carbon dioxide. So we put 6.53 grams of CO2, and I like to use all of my units so I know when they are canceling out. Then I'm going to use a conversion factor. This unit, grams of CO2, not the number, just grams of CO2, is going to have to go on the bottom if I want it to cancel out. And then based on our previous knowledge, we should know that the only thing that is equivalent to grams of CO2 is 1 mole of CO2. So on the top we can put 1 mole of CO2 is equivalent to some amount of grams of CO2. And we earlier learned that our nice, beautiful periodic table can help us figure out the molar mass. So we have carbon, which is 12, and we have 2 oxygen, each 16. So we can, on the side, carbon, 12 grams per mole, oxygen, 16 grams per mole, and another oxygen because we have 2. So that equals 32, 34, 44 grams. So now we're going to multiply 6.53 grams by 1 mole. So that would be 6.53 grams of CO2, moles of CO2. But when we divide by the 44 grams, it actually cancels out these grams of CO2. So in your calculator, you can do 6.53, don't forget your parentheses, times 1, and if you're very confident in the answer, you don't need to do this step, divided by 44, and we would get 0.15, I'm rounding here because I just want 2 decimals, grams of CO2, or grams of moles of CO2. Sorry, this is why we have erasers. So, first step's done. Now we need to know what the molar ratio between CO2 and iron oxide is. So we look back at these values here. So when we look at CO2, we know there are 3 CO2 for every 2 iron oxide. So now we're going to use the moles we found in A and the ratio we found in B to figure out how many moles of iron would be needed to complete this reaction. So we take 0.15 moles of CO2, and we are going to then multiply that by our molar ratio. So like we said before, this unit, the moles of CO2, is going to end up on the bottom. We want the moles of iron oxide, so that goes on top. So the values are going to come from, for the mole ratio, they're going to come from the balanced chemical equation, which we pulled here. So we could say 3 moles of CO2 and 2 moles of iron oxide. So in our calculator, I saved our very long number, and I'm going to multiply that number by 2 and divide by 3, and I get 0.0989 moles of iron oxide, which I'm going to round to 0.10 moles of iron oxide. Still keeping that number in my calculator. So for the final question, we're going all the way back to the beginning now. So given that we started with 6.53 grams of CO2, how many grams of iron oxide would be needed to complete this reaction? We have our moles of iron oxide, so we're going to start there. We're going to multiply that by our molar mass. So this moles of iron oxide comes to the bottom. We don't need to do another mole ratio. We've already done that. So we're going to use molar mass, which means that for every 1 mole of iron oxide, there is a specific mass of iron oxide. So we have the weight of iron is, coming back to our periodic table, iron's right here, 55.85. We have 2 of those, so we need to add that twice. And then we have oxygen, which before was 16 grams per mole, and we have 3 of those. This one might require a calculator. So I'm going to do some fancy stuff in here. I'm going to multiply my answer from before by 55.85 plus 55.85 plus 16 plus 16 plus 16. Don't forget your parentheses or this will not work. And my answer would be 15.8 grams. So if you don't want that answer, you want to know your molar mass, we can just multiply this by divide by 0.1. So our molar mass was 158 grams. All right, so that was that one. So we found that starting, if we need, if we had 6.53 grams of CO2 and we wanted to find out how many grams of iron oxide we had, we would need to do 3 steps. So we need to find out how many moles are in 6.53 grams of CO2, and we found that there were 0.15 moles of CO2. We found the molar ratio. This wasn't really a step because we inserted it down here in this second step. We took that 0.15 moles of CO2, we multiplied it by the molar ratio, making sure that our units were aligned so they would cancel out, and we got 0.10 moles of iron oxide. We then took that number and we multiplied it by its molar mass. And again, we see that these units are opposing each other so that they do cancel out. And our final answer was that we would have 15.8 grams of iron oxide that would need to be put into the reactants in order to make that 6.53 grams of CO2.